This is a lesson on rate. It's a general concept that's very important for you to understand at school and in real life. You need to know what it means, that it's quantity over time, clearly demonstrate an ability to discriminate between quantity and rate, discuss current and quantity in a variety of settings such as travel, financial, liquid flow, and finally electric current and power. Calculate rate given quantity and time, and calculate the total quantity given time and rate. This will give you the ability to handle a lot of real world applications and understand things like your electric bill at home. Mathematics is taught to you in grade 7 that you're supposed to cover the concepts of rate, ratio, and percent. A percent means you divide any number by 100, like a century, or calling a penny a cent. Ratio means you compare two numbers of the same units. So Bill collected 100 apples to Ted's 20 apples. Their collection ratio is 100 apples to 20 apples, or 100:20, which you would pronounce as 100 to 20. And it can reduces to 5 to 1, or in plain English, you say Bill collected 5 times as many apples as Ted. Rate is simply a special ratio where you always divide by time. The most common rate you're aware of, speed, 100 kilometers per hour. There's an interesting history of percent. This penny is from the year I was born, 1964. It's getting pretty much as weather beaten as I am. And it's from the Italian per cento, which means for every 100, which they were contracting at the time to PCO. And then finally PC and a little superscript O, and then diving down. So I kind of recreated it here by drawing a little PCO that mutated to this symbol here. It's kind of interesting to look up the history of our things. Common ratios in math class you'll start playing with is like Pythagoras' 3, 4, 5 triangle, the golden ratio. You'll see it, you'll be doing ratios in biology on plants and see where nature has patterns that we can work out. And to give you an example of the strength of a ratio is, let's say Jim weighs 69 kilograms and an elephant weighs 10,400 kilograms. You going to tell that to a bunch of 4-year-olds? Or are you going to say Jim weighs as much as one elephant weighs 150 times the weight of Jim? Ratios can really make things simpler. Just a lot of people find it uncomfortable to stare at them when presented like that. Rates, which is what we want to focus on, is a very specific ratio where everything is divided by time. The most familiar one that you would actually calculate is your rate of pay. So you get a new job and the boss is going to pay you $120 for the 8-hour workday. So you take the formula, rate is equal to quantity over time, and you put in your numbers, $120, 8 hours, and you get an answer of $15 per hour. So you get paid $15 for every hour you work. If you work 4 hours, you get $60. The only weird thing about numbers is of math is that they put the dollar sign in front. It's the only unit that they do that. You put the pennies on the right side. So this is said $120. You come back and say the unit afterwards. Here are some familiar rates. One is speed. Let's say you drive 200 kilometers in 4 hours. What is your speed? You write speed is equal to distance over time, and that is equal to 200 kilometers over 4 hours, and that equals 50 kilometers per hour. Now, the rate is so important, it got its own special name, speed. Why aren't they using S? It was taken up already, and they choose V for velocity, and you'll see in grade 11 why they do that. Now, why did I put these little brace brackets underneath here? Because the units are important. It's not a number 50. It's 50 kilometers an hour. So as Yoda would say, always must we keep the units. Science this is, not math. Understanding there is in units. Here's a further example of rate of pay. A plumber gets $60 for 30 minutes of work. What's the rate of pay? What you do is write out the formula, put in the values, and then calculate and box or underline the answer for me. But notice a problem. The time was given to you in minutes, not hours. Fortunately, this is a very easy conversion. You take 30 minutes and express it as an hour, which is 1/2 of an hour. or 0.5 hours. So formula, put in the numbers, keeping the units that came with them. And when you divide, you get $120 an hour. And this is about 95% of students will do this, including me when I was your age. You go, how you're paying $60 an hour? How can the answer be more than that? The answer isn't more than $60. It's a totally different unit. It's dollars per hour. It's not the same thing at all. That's like saying, how far is Toronto? And your dad says 80 kilometers an hour. No. It's 80 kilometers away. 80 kilometers an hour. Just because the quantity is an agreement, both numbers are 80, the idea being expressed is not, right? If someone says, wow, this is amazing. He's got $33 in his wallet and his temperature is 33 degrees Celsius right now. They're the same. No, they're not. So when you work a fraction of an hour, your rate of pay is much larger than what you think. So if you think about it, if this plumber worked for another 30 minutes, you would pay him $120. So the number one thing I see students do is they'll do 60 and then they'll divide by half, or they'll look at it and go, no, it should be, they'll see this and they'll answer 30. I see it so often. It's just something in how we progress.